Day 26, Honors Physics, Problem 21. This is not an acceleration problem. The car is moving with a constant velocity for the first 50 kilometers and then a different constant velocity for the second 50 kilometers. So we're not speeding up or slowing down. Yeah, there's one short period in there with the transition that we're going to ignore when it slows down from 90 to 60 during some short period of time over this relatively long period of time. And if the car spent the same amount of time at both velocities, the averaging would be easy because it would just be 75, which is halfway between 60 and 90. But the car spends more time at the slower speed to cover the same amount of distance, so the average has to be closer to 60 than to 90. The way you do this is you split this up into two parts. We have the first leg, leg 1. I'll just call it leg 1, the 90 kilometers per hour leg. And then we have leg 2 over here, part 1, part 2, whatever you want to call it. But in both cases, we're going to use our average velocity equation, is displacement over time. I'll call this 1, 1, 1, and then V average 2 equals S2 over T sub 2. So in the first case, basically what you're going to figure out here is the time it takes for each of these two legs. Essentially, the time will be the displacement over the velocity if you solve that equation, or I'll just plug in the way it is. And we can leave the units like they are. If you want to convert, you may. But bottom line is they give you kilometers for the distance, the displacement, and the speed or velocities in kilometers per hour. So if you just plug those numbers in, you have 90 equals 50 over T sub 1. T sub 1 will come out in hours. So you'll know that number. I'll let you calculate that out. Same thing for the leg 2. You're going to have 60 equals 50 over T sub 2. So you'll know T sub 2, some number. All right? So now we want to get the overall average. It says, what is the average speed for the trip, which is the same as the average velocity here. You're going in a straight line. Speed and velocity will have the same numerical magnitude. So now we look at overall, or the total. And it's the same equation again. V average is the average speed when you're going in a straight line. I'll just say V average total equals S total over T total. So we're looking for the average velocity overall. Total displacement is 100 kilometers. So our answer will come out in kilometers per hour because we're just going to add T sub 1 plus T sub 2. Those are T's. So you know T sub 1 and T sub 2 from, excuse me, the first two parts there. You plug that in, and you get your V average overall right there.